And we're moving on, 106 student, into Module 10. So in Module 10, we kind of glanced at this in an earlier video for this week. You can see that we're introduced to using logical operators. So logical operators are essentially, oh, that's not really quite what I was looking for. So logical operators are, kind of mentioned this, the idea of combining simple expressions where we're using if something is true and something else is true. Let me go back to that. So we're introduced to the idea of these are relational operators, which we saw before, but now with logical operators, we're checking to see if x is greater than 0 and x is also less than 10. This is one way to check to see if something is, say, for example, inside a range. So this will check to see if x is greater than 0, but also less than 10. So this checks to see if x is between 1 and 9, really, is what it's looking for. So this is an AND logical operator, and this is an OR logical operator. So just be aware you'll see this. Now they talk about here this thing called a short circuit. So short circuit it's really rather simple to understand, but it sometimes is not always worded all that well. So really what they're saying is if you're using an AND logical operator with a short circuit, you want the expression that is most likely going to be false to be true. So let's say you're checking some values in a database or something with your Java program, and it's more likely that the values are going to be negative. Then if x is greater than 0, then it's not a negative value. Now x less than 10, it could be negative. But if you know it's going to be negative, then this statement is automatically not true. So you would put this statement to be first, because if this has to be true as well as this has to be true, then you would want it to cancel out quickly so it can go on through the program and go to the next step. That's the idea of a short circuit, and OR works the other way around. There's this concept called De Morgan's Law, which basically says that if you had something had to be true, like say for example, if x greater than 0 and x less than 10, if these are both true, if you invert that whole expression using a NOT operator, so this NOT operator says, hey, this is true, not, that's what this NOT says. It says, nope, that's not true, this is false. That's the same thing as using a not A or not B. So this can be written this as the same way. Just the same as with OR. If you have a combined OR, if you're saying, hey, is this or this true? Not, it's false. Then that's the same thing as saying not A and not B. So De Morgan's Law is just an inverse way of rewriting a compound logical operator expression. So you should read through this. They give you some good examples of conditional statements. We've kind of seen some of these. These are really good to check to see if a value is even or odd. You can use modulus, and we're comparing for equality. Here we're checking to see if the remainder of x divided by 2 is equal to 0. So let's say that we're looking at 6. What is the remainder of 6 divided by 2? Well, there's nothing left over. It's 0. So then this resolves to 0. So is 0 equal to 0? Well, yeah, that's true. So then it's going to say that it's even. Otherwise, it's odd. So this is a really cool way to check for even or odd values. So then they also talk again about chaining. That's another way of saying you're going to be doing some nesting ifs. You can have things called flag variables where you can set some value to true or false using a Boolean data type. We've talked about Boolean data types earlier. Maybe not use them so much, but we've talked about them a little bit earlier. But we can now use them. We can say, hey, this whole expression resolves to true. We're going to assign the variable even flag to true. So we can assign this Boolean variable to this end result, which is the word true. Then we're getting into writing some methods, and we can return a value based off what we get. We probably won't use this a whole lot right now. Again, they talk about recursive methods. Recursion is a little bit beyond the scope of this class. So there's some concepts in here that are a little bit beyond the scope of our class. But so just be aware you should read through this content and become familiar with what they're talking about, at least the beginning of that. So then back in week 4, the last, well, your next assignment, I should say, we have one more big task to talk about, which I'll talk about in the next video. But your next assignment is your exercise. This is going to be worth 10 points. So far you should have done Module 8 Java Programming Activity, that's 5 points. The Water State Module 9 Activity, that's 5 points. This exercise is kind of combining, it's kind of more of a culminating project where you're bringing in all your if-else ideas. You might be using some logical operators as well as relational, depending on how you do it. But this is actually an assignment that I made, and what I'm asking you do, and you do not have sample code here, so you have to come up with that, but you are to build a project called Module 10 Java Exercise, and what I'm looking for you to do is you are playing the part as though you are a cell phone company owner. Now, our cell phone company is really simple. We don't really worry about texting. All we're concerned about is offering 3 simple plans: basic talk, standard talk, and unlimited. Not even talking about data. This is way back in probably like 2005 when we didn't have data on phones. I don't know if we did then. I don't think we did. So we're talking primarily just about being able to pay for a talking plan. So if the user, we're going to prompt the user, we're going to kind of do a survey, get an idea as to how many minutes does the user talk. So we're going to run a simple program saying something like, how many minutes do you think you're going to talk a month? And let's say the user enters 428. This number is the number of minutes they're telling us they're going to talk. Now granted, the user's going to talk maybe 1 month 200 minutes, the next month 2,000 minutes, we don't know. So we're just asking them in a snapshot time, what do you think you're going to talk? If they say 428, we're going to say, well, the best plan for you is basic talk. It's going to cost you $39.80. So we have to figure out how many minutes they're going to talk and then tell them how much they would pay and what's the best plan for them. So how do we do that? So if we look at the plan options are that the basic talk plan includes from 0 to 400 minutes. That's included for $30. They can talk more than 400 minutes, but if they do, it's 35 cents extra per minute. Yep, you heard right, 35 cents per minute extra. Yeah, we know it's expensive, but it's old school. So if they talk 402 minutes, they're going to pay $30 for the first 400 minutes, but they're going to pay for these 2 extra minutes at 35 cents a minute. Again, they talk 402 minutes. How much are they going to pay? They're going to pay $30 plus 2 minutes over at this rate. So what's 2 times 35? 70 cents. They're going to pay $30.70 if they talk 402 minutes. So you have to figure out what's the magical value between basic talk and standard talk. Well, I've kind of given it to you here. If they talk 429 minutes and they're on basic talk, they're going to pay $40.15. Well, why, pray tell, would you pay $40.15 on basic talk when you could just go to standard talk and pay $40 and have more minutes? So for 429 minutes on basic talk, you're paying $40.15 when you could pay $40 and have up to 600 minutes included. So now these numbers are essentially my test cases. I ran my program and it displayed this, the user entered this, and then I determined this output right here. And then another test case, I ran it displayed this, the user entered this, and then this output was determined. So how do you do that? So you have to use some kind of if, and the way I see it, you really almost need to use nested if statements to do this. This program runs how many times? 1 time. This is 1 time. This is 1 time. This is 1 time. So I only expect the program to run once. You do not have to use loops. We haven't learned loops yet. So you do not have to use loops. You don't know them yet. So all I want you to do, the bare minimum of this project, is to determine the threshold value between basic talk and standard talk. I've actually given you the threshold value right here. Now, if you want, you can move on and try to get it to also display between standard and unlimited, and I will give you 5 extra credit points if you do that. This is the extension part. So the bare essential is to complete the lab between basic talk and standard talk. And if you complete it between standard and unlimited, then you earn an extra 5 credit points. 5 extra credit points. So when you finish this, save it as mod10 java exercise file.java. Please upload that file. You should test it with at least these inputs. I would test with many different inputs. So you're now playing the role of being developer and tester. Make sure you test your code before you submit it. Because if it doesn't work and you submit it, then why would you submit it? Test your code. Test your code. Make sure you follow best coding conventions. Make sure you put your name at the top, file name, the date. The same kind of convention you should be following. Do the same thing and put that at the top. Alright, if you have any questions, email me. This is taking us through Module 10 Java Programming Exercise, talking about relational and logical operators. I'll be back for a brief video explaining the major project part 2.